Okay, I think we can start. If anyone will join later, there's gonna be recording available on our YouTube channel. I've shared in the common chat. Hello, I'd like to welcome you on today's super quick workshop, super quick session regarding NFT marketplaces. My name is Sam. I'm CTO and co-founder of Tatum. And what we're gonna do today, I'm gonna very shortly tell you who we are, what we do, and we'll just dive into the NFT stuff. Today we're gonna talk about ERC 1155, what it is, how we can use it in a NFT space, what can represent and what can be achieved with that. Don't be confused with the date. We had to postpone the workshop for 3 weeks, so sorry for that. But I'm pretty sure we will start doing workshop again on a regular session every 2 weeks on Wednesday. For those guys who didn't see our previous workshops, we have like 2 previous workshops on NFT marketplaces and more workshops on NFT stuff, etc., etc. Those are all available on our YouTube channel where you can take a look. So organization stuff. I'd like to ask you all to stay on mute. If you have any questions, please shoot to the chat. I'll try to answer during the session, and if there will be a lot of questions, I'll ask at the end. At the end there will be a Q&A if there's anything on your end which we clarified, and that's basically it. So let's just dive into the problematics. So as I promised, I'll very briefly introduce who we are and what we do. We are Tatum. We are next generation blockchain infrastructure, but we are not only node provider as many of other providers, but we are trying to build something more. We are trying to ease your development on the blockchain, and we are trying to make blockchain available for every developer, even though they don't have any blockchain experience. To do that, we have a lot of like pre-built PCs or pre-built functionalities, which are available for you. And today we'll see how ERC 155 could be used with our like super abstraction. What I'm going to show you today is a REST API integration, and we are going to deploy ERC 155 smart contract. We're going to mint new tokens. We're going to transfer tokens between different addresses, and we're going to read some kind of metadata or information from the blockchain regarding the tokens. All of this is abstracted in a way that you can work with ERC tokens on Ethereum or on a Binance Smart Chain, on Celo or any other chain we will support in the future. And I will show you very soon how this could be achieved. So in order to start, in order to use our API, everyone could sign up on our dashboard. It's available from our main page. You can sign into the dashboard. You can create free API key. The API key has no limitations regarding consumption. The only limitation is number of requests per second. So once you create API key, you can see it in the main overview, and this API key is used in every API request to our platform. I will share the link to the dashboard with you, and let's just talk about the 1155 tokens and what it is. I'm pretty sure many of you knows that NFTs are usually associated, at least they were associated from the past, with ERC 721 standard. This 721 standard is I would say the most popular standard these days for working with NFTs, but it has some cons, and the cons are, usually in a cost efficiency. respectively cost and efficiency when you want to mint multiple tokens, when you want to mint a lot of tokens in one transaction. With 7-to-1 standard, you cannot do that. Basically, you need to mint one token at a time, and you need to pay transaction fee for every single minting. So that's why ERC 1155 standard came into place. And with 1155, also known as a multi-token or semi-fungible token, the power of this standard is the way how you can mint new tokens. You can mint multiple tokens of the same type. Let's say we have token number 1, and we can mint 100 pieces of this token number 1. All of these pieces are the same. It represents the same token, but the quantity, the number of tokens of this specific type is 100. In comparison with 7-to-1, in 7-to-1, the token ID or the identification of the token represents the one and only one token in the world. So there is no token in the world which has the same ID in the 7-to-1 world. In the 1155, you can have basically unlimited amount of the same token IDs, and each token each like piece of the token is the same. This is super powerful when you want to create like multiple pieces of the same item. When you want to, for example, I don't know, imagine you have a game, you have I don't know, Warcraft or or something like that, and there is 100 swords, and you want to create NFT for each of that sword, and these swords are exactly the same. There's just 100 same swords in a game. So what you do in ERC 1155, you just create a token with the type sword, and you just mint 100 of these swords in one operation, one transaction. And then anyone can own, I don't know, 5, 10 of these swords. It doesn't matter. Each of the swords are the same, etc., etc. So there's a lot of use cases where you can fit the 1155 functionality, and it makes a lot of sense. So let's just, this was sort of introduction of what ERC 1155 is and how we can leverage that. And right now, let's take a look how to actually, as a developer, you want to integrate or this standard into your application, into your marketplace, and you want to enable your users to mint new tokens, to sell those tokens to someone else, and to read information about those tokens from the blockchain. What I'm gonna use today is the tool called Postman. It's a REST API client, so you can invoke any API using that, and we are going to communicate with our platform, with the Tatum SaaS cloud. I have a quite nice set of API calls or API requests, which I'm going to show you today. All of these endpoints are available in our developer zone, where you can find a nice guide regarding 1155s. And I believe there's also this Postman collection available for download. If not, I will share it. I will add it to this guide after the workshop. So again, I will send this guide to you, so you can take a look in the future about 1155s and what is going on here. So first of all, everyone needs to, if you want to work with smart contract, you need to deploy it. You need to deploy it to the blockchain, and you own your own instance of that. And in that instance, you will create tokens, NFTs, will transfer them, etc., etc. For 1155, we have the multi-token endpoints here. And first step you need to do, you need to deploy your own instance. You can see we don't do any Solidity stuff here. We don't do any like coding of the smart contract. The smart contract we are deploying is already coded from our end. We are using OpenZeppelin standard smart contracts We sometimes add one or two features to that, but these smart contracts are just the standard ones. If you want to work with yourself, with your smart contract, and if you want to add some custom functionalities, you can. We do not force you to leverage anything, but this is for like 95% of projects. The standard ones are just fine. So first of all, what we need to do, we need to deploy the contract, and the API call is quite simple because there are only 3 parameters you need to provide, and each of them are important. First parameter is chain. In this parameter, you decide which blockchain you want to work with. Right now, I'm going to deploy to Ethereum, to Postman, but I can choose to deploy to Binance Smart Chain. I can choose to deploy to Celo. And more blockchains we will support in the future with the 1155 capabilities. We will just add a new type of chain you will work with. So this is super powerful if you want to build cross-chain or multi-chain marketplaces or leverage NFTs on multiple blockchains. You will do the integration once to our platform, and you just change the chain you want to work with. So as you understand for sure, this is a huge time saver. This is a huge cost saver because you don't need to reintegrate to different blockchain, and you are not dependent on a specific blockchain. And this is a huge thing. This is a huge topic because being dependent on one blockchain could kill even a great project, because you never know what will happen with the blockchain. You never know how gas price will rise in the future. And for all of us know that right now Ethereum is super expensive. The transaction cost is quite high. It was even worse at the times where minting one NFT cost $100. It's just a couple of months ago, and many of the projects who were dependent on Ethereum only just closed or were basically it wasn't usable for common users. I don't want to pay $100 for minting one NFT, which I will sell for $10, for example. It doesn't make sense. So this dependency on a blockchain is handled via this integration, where you can just choose and migrate to different chain basically in a couple of minutes. Second of all is the private key of the account who will deploy the contract and who will be able to mint new tokens. And the last parameter is URI. This is the URL of the metadata, which will be associated to a specific token. Usually, when you use URI, you are adding some kind of ID of the token, and each token has its own metadata. For example, token number 1 could be sword, token number 2 could be helmet or shield, etc., etc. And using this like some kind of parameter inside the URI, you just say that every token I'm gonna deploy has the same URL. The only difference is the ID of the token I'm gonna work with. So we have said that we will work on Ethereum. I have already deployed the smart contract because it could be quite a long time to deploy or wait. You can see I have deployed it 3 hours ago, and we have a transaction here. So we have a transaction ID of this operation, and right now the second, or maybe we can just input with the API as well right now to see that something has happened. Second thing you need to do, you need to obtain the contract address, the address where the smart contract were deployed from this transaction. We also have a nice endpoint just to check if the contract address is available from this deploy operation. I don't know how long will it takes for transaction to this is Binance scan, not Etherscan. Sorry for that. So let's check the transaction here. Okay, it's already successful. so we can check the contract address. We can see that this is the contract address. So this is the address of the smart contract we have deployed to the Ropsten, and every operation, every mint, every transfer, every burn will communicate with this smart contract. So let's just say we want to mint a token. We're gonna mint token number 1, and we're gonna mint 10 like pieces of this token. We can mint 100 pieces, we can mint 1,000 pieces, it doesn't matter. We are basically saying how many copies of the token number 1 we are gonna create. So let's say we are gonna create 100 tokens. We are gonna mint it on the Ethereum to this address, and this address is the recipient of these 100 tokens we are minting. Again, the result of every like write operation on blockchain is always a transaction ID, and we can check if the transaction is successful or not. There is again nice like method to check the details of the transaction. We just choose the chain and the transaction ID. I'm pretty sure the transaction is not yet in the block. We can see that block number is 0. So we need to wait a couple of, I hope, seconds, not minutes, until the transaction will be processed by the blockchain. Once the transaction will be processed, what should happen is that on this address, there should be 100 tokens number 1. If we want to see that data, if it's correct, we again has a nice operation. We want to find which tokens are, or how many tokens are present for this smart contract on this address. Again, we can choose chain, which is Ethereum. We are saying that we want to see the balance of token number 1 for this recipient with this smart contract. So let's just check it. There's 29 tokens. I suppose I have used the wrong contract address for that, but we can see from the mint operation. Get tokens by address. I think I didn't use the correct contract address from the let's see one more time. Okay. Yeah, I have used the wrong contract address. Sorry for that. So let's just mint that one more time. And the previous transaction is not yet processed by the blockchain. So we need to wait a couple of times. But when we take a look to this endpoint back and we'll see the previous contract I was working with, we can see that this address owns 29 of token number 1. When we will mint the correct tokens on the correct contract, there should be 100 of those. So this operation is useful if you work in on your marketplace, you want to display your users how much tokens he owns, or you want to do some kind of identification of which address owns how many of the tokens, etc., etc. So let's just try to mint. Yeah, the transaction was completed, the previous one. So let's check this one. And we need to wait again a couple of times until the transaction will be processed. Okay. What we added as like additional feature for you to this smart contract is that you want to mint multiple tokens to multiple recipients in one operation. This is again super powerful because yeah, this minting is like the standard minting. I want to mint 100 token number 1s, but what if I want to mint, I don't know, I know that I need to mint, for example, 5 different tokens to 5 different recipients with 5 different like amounts or how many of those tokens that should be. So we have added a batch mint operation where you can say, okay, I have 2 recipients. I'm going to mint token number 1 and token number 2. This token number 1 will go to this recipient. This token will go to this recipient, and this is the number of tokens I'm going to mint. So again, this is even more like cost-effective operation for you if you know that you will mint a lot of different tokens in one call. you can save a lot of transaction cost, and also you will save a lot of like waiting for blockchain to process the operations. So let's just mint, I don't know, token number 11 and 12 in another transaction again. Let's just check if we have this 100 token number 1 on the address. Yeah, we can see that we have 100 tokens of token number 1. When we mint multiple tokens, we will also see that there will be different tokens with different balances. So this is great. So what you can do now, you can deploy your own 1155 on the fly. It doesn't mean that you need to create, for example, you want to start a new application. At the beginning of the application, you will deploy your token. And during the lifetime of the application, you just using one token, one ERC 1155. That's perfectly fine. But there are use cases where you want to deploy new contracts on the fly. Imagine you are building some kind of a platform where you want to enable your users to deploy new contracts and mint new tokens on the fly before any like previous setup. So this deploy operation is super powerful also for this use case, where you can do it on the fly for your users without any coding, without any development, etc., etc. So this is a new, like new perspective or new areas of the application where you can leverage that. So we know how to deploy, we know how to mint. What's missing is transfer. And again, the transfer is, again, super easy. You need to specify the recipient you want to transfer the token, contract address, blockchain you want to work with. You need to specify the private key of the account which owns the token you want to send. So this is the sender account basically. And you are saying that I want to send one token number 1. So I'm sending one token to this recipient. So let's just send it, and we will see at the here in the balance that I still have 100 because the transaction is not yet settled by the blockchain. But once the transaction will be settled by the blockchain, will be included, we will see that the balance of the sender will decrease. It's not going to be 100, but only 99, and the recipient will have 1 new token. So let's just check the recipient right now. How many tokens he owns? We see that he owns 0 and the sender owns 100. So once this transaction will be settled and included in the block, we will see the change of the balances of the tokens. So again, this is another important operation in your application. You need to mint, you need to transfer to someone else. The last operation, which is like modifying the state of the token on the blockchain, is burn. If you want to, when you burn, you basically destroy the token. It will never be available for use anymore. So burning, it has basically or you can use the burn operation in 2 use cases, at least like from my mind. First operation is that you want to just destroy the token and the representation of the token. For example, your logic is that the tokens will represent some kind of one-off operation, and once the token is used, it should be destroyed. So you need to burn it. Second use case is when you want to do the cross-chain transfers you want to transfer the token from one blockchain to another. Imagine you have like a multi-chain application. You are working with Ethereum, with Binance Smart Chain, and I don't know, with Tron. And you mint the token, and you have smart contracts deployed on each of these blockchain. And you have minted a token on Ethereum. You sold it to someone in your marketplace, and that guy wants to transfer the token from Ethereum to Binance Smart Chain because Ethereum has super crazy fees. So what you should do in order to transfer it between blockchains, like basically it's not possible, like from the technical perspective, it's not possible to transfer data from one blockchain to another. So as a workaround for that, you will burn the token on Ethereum and you will mint the same tokens with the same parameters, with the same metadata as the burned token on the mainnet smart chain, on the new blockchain. You can also include like the full history of that burned token on Ethereum inside the metadata of the newly minted token. So we will connect the history from Ethereum to Binance Smart Chain inside their metadata. So this is the second use case where usually people are using burn when they do the cross-chain transfers of the tokens. Okay, I hope the transaction is settled. So let's just see the data, and we can see that the recipient has one token, and the sender has 99. At least he should have. But yeah, it's like that. So from the burn, again, we can just burn one token. Let's just enter the correct contract address so I will not be mistaken again. And let's burn, I don't know, 15 tokens, number one. Let's burn just 15 of them. So we'll again wait for the transaction, and we should see after the burning that the balance of this guy should be not 99, but 84. So that's burn. We have covered all like write operations. We have covered deploying, minting, transferring, burning. I have shown you how to see the balance of the token. I have shown you how to fetch for the contract address, how to check the details of the transaction. But what I didn't show you is, when we were deploying the token, we were assigning some kind of a URL. And this is super important in the NFT space because this URL represents the token as such, or what it, the data the NFT represents. Usually inside the metadata, there are information about the token, about the issuer. I don't know if it's video, link to the video, if it's a picture, link to the picture, etc., etc. This URL is usually like pointing out to some kind of a decentralized storage, like IPFS or Filecoin or stuff like that. Yes, you can add their AWS S3, but if you want to like leverage the features of the blockchain, which means the data won't be deleted and no one can modify it, you don't do S3. And every token you are minting has some kind of information about it. So once the user is, for example, buying a new token on the marketplace, he wants to actually see which metadata he's buying or what does this token represents. So in order to find this metadata, we have an endpoint to read the metadata information from the specific token. And we can see that for the token number 1, the metadata is 1.json. If we will use token number 10, the metadata will be 10.json. And now it's up to you to represent correctly the metadata scheme this URL is pointing to. I hope the burn transaction is already settled, and we have 0, which is not correct. Probably some error somewhere. We can take a look here. How many we burned? Oh yeah, I understand. The burn as such is destroying all the tokens, not this amount. So this, I think, is not required. Right now, when we burn, we burn all the token IDs. We burn all the like copies of the token. So we just burned all of them. So that's my fault. I have wrong API request. Sorry for that. And I'm pretty sure I'm done. I have shown you like every API call we had here, and as I said, we have covered all the deployment stuff, all the minting, burning, and transferring, and all like read operations, like find out the balances, find out the metadata, etc., etc. Yes, Patricio, we are gonna add this recording on a Zoom, recording of the Zoom to the YouTube channel. I hope it's gonna be today or tomorrow in the morning. I have like 5:30 p.m. So it's gonna be my morning, but US it could be late night. Now it's time for question and answers, and I'm happy to answer any question you might have. How to start? What do you mean, Eva? How to start? How to start with using the API? I have shown the dashboard where you can sign up, create API key. I will share this Postman collection in the guides for 1155, and there is also some kind of a short description regarding the API and request you need to invoke. There is also the link to our API documentation, which is a little bit more like more explaining, because there's a lot of text and a lot of examples for different operations. Can we control what is data used to mint the hash or CID of the NFT? I'm not sure, Guillermo, what's the question? Can we control what is data is used to mint the hash? Can you be more like more specific, please? Maybe, Guillermo, regarding the CID and the data, we also have an integration for IPFS. So what you need to do is basically you can just upload the file to the IPFS directly. The result is the IPFS hash, and you can store this IPFS hash or CID to the NFT token. Another platforms when minting an NFT, they usually use the actual binary code from the image to mint the CID to ensure uniqueness. Okay, I understand. Well, we just give you the tools how to mint the token. How you will do it actually on your end, it's up to you how the integration and implementation will look like. We just give you the way, place here the metadata, and that's it. How the metadata will look like, it's definitely up to you. We are not forcing anyone to do anything or do some kind of standards, because basically you will create your own like platform or application or marketplace where you will apply your own business logic around this. Okay, guys, if you don't have any more questions, I think we can just call it. feel free to join our Telegram. Feel free to ask there, or you can write mail to hello@tatum.io. But the Telegram channel is the best place to start and ask questions. Either me or our guys or community will be there, and we'll try to help and answer anything.